Good morning and welcome back to Pre-Algebra with Miss Betsy. Today we're going to continue our discussion concerning rational expressions by learning how to add and subtract rational expressions that have the same denominator. If you are using the same text as I am, go ahead and turn to chapter 12.4 in your text. You would be beginning on page 491, and that text is Algebra 1 for Christian schools. It's been published by Bob Jones University Press. It is the second edition that I'm using. If you don't have that same book, no big deal. You're going to be adding and subtracting rational expressions using the same principles and procedures regardless of what textbook you're using. Before we get started though, my question for today is, what do you get when you cross a dinosaur and fireworks? Well, you would get dynamite. So let's think back to what we mean when we're talking about a rational expression and what a rational number is. We learned that a rational number is something that you might commonly think of as a fraction. 4/5 would be a rational number. What the definition of a rational number is, though, we say that that is something that can be written in the form a over b. B has to be different from 0, and A and B have to belong to the set of integers. So what we commonly think of as fractions are actually rational numbers. And then we went on and we learned that we can also have rational expressions, and the pattern for those would be that you had, rather than a simple integer in the numerator and in the denominator, you could use polynomials. X squared plus 2x plus 3, all of that over x plus 1 is a rational expression, and our formula or definition for that looked really strange, but it was a capital P sub 1 divided by P sub 2, where P sub 2 cannot be equal to 0. And all that means is, as long as you've got a polynomial in the numerator over a polynomial in the denominator, and there's nothing, and you select your value for your variable so that you don't get a 0 in the denominator, then that qualifies as a rational expression. And you'll remember that the reason that our denominator cannot have a value of 0, which is why we have the same caveat over here when we're describing what a rational number is, and we say that the denominator here can't be equal to 0. The reason for that is we have learned that division by 0 is what we call undefined. If I asked you to tell me what's 5 divided by 0, there isn't any answer. The answer is not 0. 0 divided by 5 is 0. 5 divided by 0, we don't have any answer for. So we say that when we divide by 0, that answer is undefined. We don't have a way to describe it. So this expression right here is a legitimate rational expression as long as our denominator isn't equal to 0. Are there any values that this would be 0? Well, yeah. If we had x equal to a -1, we would end up with a 0 in the denominator. So for all values of x except -1, this is a rational expression. So anyway, there's that quick review of what rational expressions are. And now, in today's chapter, we're going to learn how to add rational expressions. Now, if we wanted to add rational numbers together, and we had 4/5 plus 3/5, because we have the same denominator, you add the numerator, and you end up with the simplified improper fraction of 7 over 5, which is how we like to keep our fractions in algebra. When the denominators are the same, you simply add the numerators. You simplify if necessary. We also know that if we had 4/9 plus 1/3, that answer was not going to be equal to 5/12, but that we had to get a common denominator here, which would be 9/9. So this would be, once you came up with a common denominator, our sum here of 4/9 plus 1/3 was 7/9. Just like you have to have a common denominator to add rational numbers together, you also have to have a common denominator to add rational expressions together. However, you get a slight reprieve because in this lesson, all of our denominators are going to be the same. Next lesson, we'll learn how to find a common denominator using rational expressions. So, I want to go ahead and look at example number 1 on page 492, and it says simplify 4 over x plus 9 over x. This is example 1, 4 over x plus 9 over x. We look and see that the denominators are the same, they're both x, so we simply add the numerators together to end up with 13 over x. And that's all that there is involved in simplifying this sum of rational expressions. Very, very easy, very straightforward. Same principles, as long as the denominators are the same, you simply add the numerators. There's nothing else you can do on this problem. So at its most basic, most simple level, this would be an example of how you add together two rational expressions. But now let's move it up a little bit more to something that's not immediately obvious. Say that we have, if I can read this here, 3x squared plus 4x minus 8, all of this over x plus 2. We're going to add a second rational expression, x squared minus 3x, x squared minus 3x minus 6, all of that over x plus 2. And you see what we have here? Two rational expressions, polynomial over polynomial, that we're adding together. What's the first thing that you do with rational expressions? You make sure that the denominators are the same. The denominators are the same, which is the entire factor of x plus 2. When the denominators are the same, you simply add the numerators together. So we have 3x squared plus 4x minus 8 plus x squared minus 3x minus 6. All of that is over the denominator of x plus 2. What are we going to do? Combine like terms. 3x squared plus x squared is 4x squared. 4x minus 3x is plus x. Negative 8 minus 16 is, negative x minus 6 is a negative 14. All of this over x plus 2. Now let's see if that's what I end up with. I have 4x squared plus x minus 14. All of this over x plus 2. Are we finished? Well, if we had 12 over 16, is that a complete answer? The final answer? No. 12 over 16 has a common factor of 4, so 12/16 has to be reduced to 3/4 before we can know that we've completed our problem. We have the same thing going on here. Remember I said you're going to be factoring and factoring and factoring? We have a trinomial in the numerator that we're going to need to factor. So I just erased what that intermediate step was, so let me go ahead and copy that from my book. So we have 4x squared plus x minus 14, all of this over x plus 2. So what are we going to have? We're going to have to factor this into two binomials. And you're going to, both of these are going to be negative. Would that be true? Negative times negative gives us a positive. We have a negative constant term, so one of these factors is going to be positive. One of them is going to be negative, and we need to figure out what the coefficient of our x term is and what our constant term is. This is one of those trial and error ones. How many ways can you factor 14? 14 can be factored as 1 times 14 or 2 times 7. 4 can be factored as 1 times 4 or 2 times 2. And we're going to have to arrange the factorization of these numbers over here so that when we do our FOIL, when we multiply back, we end up with a plus x as the middle term, a negative 14 as the final term. So let's look and see what we can do. Now, a lot of the time when you have wildly differing values for your factorization, usually you're not going to have the 1 times 14 or even the 1 times 7. So I'm going to try 2 and 7 first and see what happens here. How about if I put x minus 7 and 2, positive 2 over here, because negative 7 times a positive 2 is a negative 14. Now, I can either factor, have my coefficient here be a 1 and a 1, or a 2 and a 2. Let's try 2 first. 2x minus 7 times 2x plus 4. So we have 4x squared, but we have plus 4x minus 3x. That doesn't work. What happens if we change the position of our 7 and our 2? Well, that's getting worse, isn't it? 2 times 7 is 14, minus 4 is 10. Okay, so I'm still going to stick with my thought that I'm going to need a 2 and a 7 for the factorization of 14. So, now let me go ahead and try multiplying with coefficients for x of 4 and 1. And I'm deliberately taking a little bit longer to do this. 4x and x. Well, 4x times 7, 28, that's really bad. So let's put our 4 for our second term and see what happens. X times 7 is plus 7x. Negative 2 times 4 is negative 8x. That gives us a negative 1. But at least we have a sum of 7, a sum of 14, and a product of 1. So we probably will just do this right here, and our problem has gone away. X times negative 7, x plus 8x minus 14. So this is our factorization. All of this over x plus 2, which travels together as a factor. Now, I've said this to you before, but you saw all of, it took me a while to come up with the factorization of this, deliberately so. If I had looked down here in the denominator, and I saw that I had an x plus 2, these problems are artificially manipulated just to teach you how to reduce and cancel common polynomials. If I'd looked at that, I would have thought, I bet you that x plus 2 is one of those factors, and it would have taken you less time to be able to simplify this problem. So that the way that I just worked that was to illustrate to you that take advantage of pieces of information that might be true. Like it's more likely that the 2 and 7 were going to be the factors that we needed, but I completely ignored the fact that we had x plus 2 as a denominator, and I had to go through four trial factorizations before I came up with the solution. So now we have an x plus 2 in the numerator, an x plus 2 in the denominator, and the final result to that sum of two polynomials is 4x minus 7. Now, let's go ahead and do another one. This is example number 3. We'll see what we have here. We have 2x plus 9 over x minus 4 plus 3x plus 2 over x minus 4. Again, the denominators are the same, so we add the numerators. 2x plus 9 plus 3x plus 2, all of that over x minus 4. Now we simply combine like terms. 2x plus 3x gives us a sum of 5x. 9 plus 2 is 11. Plus 11. All of this over x minus 4. Is our numerator factorable? Is there a common monomial factor with 5 and 11? Well, no, they're both prime numbers. So this can't be factored. You have nothing in common that you can cancel. Remember, you cannot say I'm going to cancel out those x's. You can only cancel factors. You cannot cancel like terms or things that just look like they're the same. You can only cancel common factors. So the sum of these two rational expressions with the common denominator of x minus 4 is very straightforward. 5x plus 11 over x minus 4. So what are we going to do if we subtract rational expressions? We're going to deal with those exactly the same way, but we're going to be careful to remember that we're subtracting the entire numerator. We're going to distribute the negative sign as we combine those two rational expressions. Page 492, example number 4. 4 over x minus 8 over x. Common denominator, subtract the numerators. 4 minus 8 over x gives us a negative 4 over x. Straightforward, nothing to teach here. But let's go ahead and look at example number 5. Two plus x over 8 minus x minus 9 over 8. Okay? This is what they want you to do. Not necessarily that they want to, but this is the trap that they are laying for you. Let me do it right here in a different color. This is wrong. 2x plus x minus 9 over 8. What's wrong about this? We're just saying 2 plus x minus x minus 9. Well, this doesn't say that we're subtracting x. It says that we're subtracting the entire expression, x minus 9. This is what it should look like. And that should not be 2x. That was not the problem. That was me just speaking and writing. 2 plus x minus 9. That's wrong. So that negative is the problem. And I'll illustrate for you. It's actually 2 plus x minus the quantity x minus 9 divided by 8. So we're saying a negative 1 times x, a negative 1 times a negative 9. This is distributing a negative. When you distribute a negative sign, remember that the sign of every term inside the parentheses reverses. So we end up, I hope, with 11/8 as being the solution to this problem, which is exactly what it is. X minus x, our variables cancel out. 2 plus 9, because we've subtracted this entire quantity. Be on your guard for this. This is what happens so much. We forget that we're subtracting an entire quantity. That's why you should always go ahead and put parentheses and close what you're subtracting or multiplying or whatever. And close that polynomial in parentheses, and then you're much less likely to fall into this trap of dropping a negative sign. Okay? See, we have another problem. Final problem that I'm going to illustrate from our textbook, from our example. And I'm going to make sure that I get this one copied correctly. This is example 6. And it says 3x squared plus 3x minus 20, all of this over 2x squared plus 18x plus 40. And we're going to subtract from that x squared plus x plus 4 all over the same denominator, 18x plus 40. So let me go ahead and make sure 2x squared, 18x, 40, we have the same denominator. Let's check the numerators. 3x squared plus 3x minus 20 minus x squared plus x plus 4. Take the time to make sure you've copied it correctly. Denominators are the same. Subtract the numerators. 3x squared plus 3x minus 20. Now we are going to subtract the entire numerator. So I'm going to enclose that in parentheses, plus 4. All of this over our common denominator of 2x squared plus 18x plus 40. Okay. And close this in parentheses because the signs of all of these terms in the numerator of this second rational expression are going to change. We now have 3x squared plus 3x minus 20 minus x squared minus x minus 4, whoops, x minus 4, all over our same denominator. 2x squared plus 18x plus 40. Now we combine like terms in this numerator. 3x squared minus x squared. 2x squared plus 3x minus x is minus 2x minus 24. All of this over 2x squared minus 18x plus 40. Now let me go ahead and make certain that I've done this correctly. Quite sure I have 2x squared plus 2x. Well, I said I was quite sure I'd done it correctly. And I haven't. 3x minus x is a positive 2x. That would have frustrated me. 2x squared plus 2x minus 24. All of this over our denominator of 2x squared minus 18x plus 40. Are we finished? No, we're going to have to simplify it, and I hope that you noticed already that we have a common monomial factor in both the numerator and the denominator of 2. So, I'm going to erase what we have here and begin again. As I transfer this to the top, I'm going to take out our common monomial factor. 2 times the quantity x squared plus x minus 12. 2 times the quantity x squared minus 9x plus 40. We have a common factor of 2. Now we have two polynomials that can be factored very easily by inspection. So let me go ahead and show you the factored form of this. We're going to have two binomial factors in the numerator. Our sum has to be a positive 1. Our product has to be a negative 14. So we know the signs of these binomial factors are different. 3 times 4 is 12. We put a negative 4. We put a negative 3 and a positive 4 because we want their sum to be a positive 1. No coefficient in front of the x squared. So the factorization of x squared plus x minus 12 is x plus 4 times x minus 3. Now let's go ahead and factor our denominator, x. And let's see what are the terms, what are the signs in the middle of these two factors going to be. Well, we have a negative sum and a positive product. You multiply two negatives together, you get a positive. That's very interesting. I'm not having this drop out the way I want it to. X plus 4. Aha! How many of you kids caught what I did? I'm doing this as extra teaching for you, where I take the time to go through and teach you every single section in the book to the best of my ability. Let me show you what I did here. This original denominator was 2x squared, and then I'll explain to you how I knew I had a problem. 2x squared minus 18x plus 40. And when I transferred from down here at the bottom of the board up to the top, I was reducing or factoring out a common monomial from both the numerator and the denominator. First one I factored correctly. 2 times the quantity, x squared plus 2x minus 24. The second one I didn't factor correctly, did I? This right here should be a positive 20, not a positive 40. Now, how did I know that I had a problem going on here? Well, a couple different ways. I can't factor 40 and then, and end up with a negative 9, I don't believe. 40 would be 1 times 40, 2 times 20, 4 times 10, 5 times 8. I'm not sure how I would end up with a 9. Two negative numbers together is going to give me a negative 9. That was the first thing that clued me in. But also, remember what I said earlier in this lecture? I said when they're teaching you how to cancel common binomial factors, you can expect one of the you can expect to have a pair of like factors in your numerator and in your denominator. And 4 and 3, they're not showing up here, so that told me I had a problem. Figured out what the problem was here, so now I'm going to make the correction. If you didn't follow exactly what I said, rewind your video a little bit and you'll see what I did. And then bring it forward to where I have corrected it. X squared minus 9x plus 20. Now I need factors of 20, that their sum is a positive 20, that their product is a positive 20, their sum is a negative 9. And now I'm going to have exactly what I'm looking for. Oh, this is such a hoot. X squared plus x squared, 2x squared plus 18x plus 40, 2 times the quantity x squared plus 9x plus 20. Once again, I saw the problem because I couldn't get this to factor properly. All right, -4 and -5, but I didn't have a common binomial factor that would cancel. Now I hope for those of you who have stuck in to this point in the video, you've seen that these problems don't always fall out really, really easily for you. This is not a difficult problem, and God has given me an ability to do this algebra. But you miss a sign, I've told you those signs will trip you up, and what you saw is I'm having to go back and back and back and figure out, oh, well now I know what I did. So since I had x squared plus 9x plus 20, I have 2 positive factors. I have a positive 4 and a positive 5, and now I am finally at the point where I see that I have common factors I can cancel here. What I just illustrated for you is why I recommend strongly that you have access to a teacher manual or to a solutions manual. Lots of teachers don't agree with me, but that's what I did when I went back to school to get my math degree. I got every teacher's manual that I could. I got the solutions manual that I could because I used them as teaching tools for me. As with these math classes, there's no way a teacher can teach you everything that you need to do yourself. There's simply not enough time. And even with these videos that I do, there's not enough time to learn everything. But if you have resources available to you that show you what the correct answer is, and you are willing to apply yourself and put the time into it, you can backtrack and say, oh, I see what I did. I see what I did. I see what I did. Now I understand. We have now common factors of 2, common factors of x plus 4 that cancel, and we end up with x minus 3 over x plus 5 being the solution of this example, which is example number 6 on page 493 on your text. And I'm actually going to go ahead and send out an email to you guys saying, if you don't watch any other video, watch this one, because it's a good one. Now, I tell you what, when you come into class on Friday, for those of you who are in my local class here in Texas, bring me a piece of paper that says, I watched the video, and I'll give you 3 points bonus on your next test. Okay? This is your bonus for having stuck through to the end of watching this video. Don't tell your friends. You just come in with that piece of paper, hand that in with your homework that says, Miss Betsy, I watched the video, can I have my 3 points bonus? And that will be your reward for doing this. Now the last thing that I want to mention for this section, this is in the bottom part of page 493, and it talks about finding the GCF of those two original polynomials, that way you can just cancel common factors. Well, that's exactly what we did. We had a common factor of 2, we had a common binomial factor of x plus 4. But we'll deal a lot more with that as we move on later in this chapter. That's the end of today's video. I'll see you next time.